and no walking in front of it, okay?
Yeah.
And I think what I'll do is I'll work on that board over there. Ooh, that's a little bit too much of a zoom. We'll see how that goes. All right, so we're taking a look at the lesson master. What is it 1-3? Is that the lesson master?
1-2A.
Oh, it's 2A?
Yeah.
Okay. So what were the three digits again that are given?
9, negative.
9, -6, and -2.
-9
-2, -6.
and -6. So how do we take those three and put them in order with a double inequality? Phoenix.
You put 9 first, then 6, then 2.
Like so? And then which symbol should we use? Less than. Okay, so what if you chose to use greater than?
Flip it.
It'd be 2, 6, 9.
-2. -6 is still in the middle, that's -9. So put them in order from greatest to least. If you use greater than, from least to greatest. This is the one that I think I said I wanted you to be doing, yeah? Okay. Then, how did the rest of this go?
Quite easy. Pretty
Are
easy.
you okay with it? Do we need to go over any of it?
No?
Should we move on?
Yes. Yeah.
All right, we're gonna move on. So then, the lesson is 1-3, rational numbers and their uses. So in your notes notebook. So the first thing we gotta do is identify what is a rational number. We need to know that before we start talking about rational numbers. Have you heard the word before, in terms of numbers?
Sometimes.
I know we said something about it last year, but that doesn't mean that we remember, you know, that was a ways ago, and we probably didn't walk around all summer talking about rational numbers and substituting for variables and things like that. That's probably not part of your summer conversation? Not likely, no. So, TJ, you had your hand up.
I think my thing was wrong with I saying, just on the dictionary, basically. Rational? Rationable?
Realistic.
Yes, that's what I meant, like, that's what I meant, like, it was, like, it could actually be the answer, and it's not gonna be like 1 minus 2 is like negative 560.
Yeah.
Like estimating a number.
Hey, grab your graphing calculator. Grab your calculator and help me out. Yeah, keep it in here unless I tell you you need them for homework though, okay? But, Rylan, there, look at, is that your box? His box?
Well, it has your calculator in it.
I had.
Okay, so is that your ruler?
That's your ruler, and that's your book, so, there it
Is
is.
that your book?
Okay, so do this for me. Take, on your graphic calculator, I'm just gonna scribble off to the side, you don't need to write this down. Well, maybe you should, yeah, let's do it. Take 10 divided by 2. Can you do that?
Yeah.
Yeah.
And what are you gonna get?
5.
5. So that's a number that makes sense, it's rational. Do this, take 1 divided by 3. What does that turn into?
Point 3.
0.3, and it keeps going, right? So we would write that 0.3 repetent. That's rational. Because we can say that this 3 goes forever. And because it goes forever, we could go backwards and we could say that that came from 1/3. So 1/3 is rational. 10 over 2 is rational. Is the number 6 rational?
No.
It's just 6, right?
Yeah.
There's not some crazy imagination that you have to be able to try to formulate as you think about that number. And we could actually write it as 6/1, correct?
And
It's
that
the
would be
same.
rational?
So it's rational. This is a fraction, it's rational, that's a rational number, that's a rational number.
So any fraction is a rational number?
That makes
Yes. A rational number can be written as a simple fraction. Now, pi. What is pi?
3.14.
So hit the pi key. You have to hit enter again? I can't remember. Yeah, I think you do. Hit pi and then you hit enter. You get 3.14. Oh, pi is on the left. I believe it's a second function.
No, it's on the right.
Oh, it's on the right, and it's a second function. So you have to hit the blue key and then the up arrow. Not the up arrow, the,
3.14.
here it is.
Yeah.
So you gotta, so hit second quick to get out of that. If you get something that says ERR on your calculator, hit second and then the mode button right next to it. Now, second, and then that. There it is, and then hit enter. Can you all get it to display?
Yes.
Second, and then this. Nope, you hit that one. Second, nope, you hit the wrong one. This one, the arrow. See the blue one there? That's what you want. There, now hit enter. Can we all get it? And they're not? All right, so what does it read? 3.14?
1592654.
Like this? What if you had more place values? It would keep on going and going and going, and there would be digits that would constantly come up. They would be never ending. And there would be no pattern whatsoever to it. And because there isn't a pattern, we can't write it as a fraction. Pi is not rational. Do 2 divided by 7 on your calculator. How does that come up?
Mine hit 0.
Okay, so now type 2 divided by 7 equals.
I did.
2 divided by 7 equals.
Oh, so
Enter.
a rational number is like a fraction that equals something, that makes sense. Like something with a pattern. Yeah.
Some John Denmark. Okay, as we find out. So what I have to do, okay, we have to check that one back in and check this one out. I know it's got a glitch in it, it needs to be reset, we're not gonna take time now. So what do you guys get when you do 2 divided by 7? 0 point?
28571.
I need just one person, help me. Emma.
I just accidentally raised my whole.
Okay, somebody, Stacy?
28571428557.
Okay, so if you take a look at this, the 285 shows up again here. So from this point where it shows up all the way back to there, that's gonna repeat itself over and over and over. So it's gonna be 285,714, 285,714. That's what will happen. This will be the repetend right here. So that makes it rational, because we have this repeating pattern that goes forever. Instead of with pi, there's this, who knows what it becomes. We can predict something. We can predict with this. Do 1/6, 1/6. What do you get? 0 point. Say it again, louder, Clover.
.16666666667.
So the 7 means that the last one got rounded up. So this ends up being 0.16 with the repetend over the 6 only. But it's a fraction. So a rational number fractional numbers is another way to name it, I'm not certain. That's a good question. We use rational, because then we can just say anything else is irrational. So there's the rational numbers and the irrational numbers. They're all a part of the real number group. The real numbers are what you know about. Every number that you've ever been exposed to is what is called a real number. There are imaginary numbers, but we don't treat you to those for a couple more years. Aria?
So what's the definition of a simple fraction?
Simple fraction is a fraction that is or can be written in lowest terms using integers for the numerator and or denominator. So we would not write 1.2 divided by 1.16, for example. You could change this, and you could change it to 120 over 116, and then simplify it. But we would write it as a simple fraction. That's simple, that's simple, that's simple, all the way through. Okay, one last. I would like you to enter the square root of 2. Now, to get the square root symbol, here's what your key sequence is going to be. You're going to start with the second key, and then it is a key
X2.
x to the second power. So what you're doing is you're looking for the blue radicand symbol. So when you hit that, up comes the symbol, then you're going to type the number 2, and then you're going to hit the equals or the enter key on the bottom right-hand corner. So what do you get for that number? 1 point,
4, 1, 4, 2, 1, 3, 5, 6, 2.
does it look like there's a repeating pattern?
Not really.
So if there's not a repeating pattern, it can't be written as a fraction. Not rational. That's irrational.
See that square root symbol?
Yeah.
So rational numbers are going to include anything that can be written as a fraction. Or if it's a decimal number, it's going to have a repetend. If it's a square root, the only rational square roots are going to be the perfect squares. You know, things like the square root of 1, the square root of 4, of 9, 16, 25. Those all come from 1 times 1 and 2 times 2 and 3 times 3 and so on. Those are the only square roots that are rational. The square root of 8 is in between these two. Remember that from last year. It can't be written as a fraction because it has no repeating pattern to it. Okay, so that's what a rational number is. So how do we use rational numbers, or what do we use them for? Let's go to the other board. So how they're going to show us that we use, I mean, we use them for all kinds of things, obviously. But rational numbers can be used when we have a count of something. So like if you're counting 1, 2, 3, 4, 5, 6, 7, 8, 8 students. The count is 8. The counting unit would be students. Sometimes we just call that units. So if you have 8 students, there's the count, there's the counting unit. So that's one way that we use them.
Did we go over it?
I'm sorry?
Did we go over that?
Yeah, we did. But another way that we use them is when we work with rates and ratios. Because rates and ratios, as we saw last year, can be written as fractions. Rates and ratios are rational. Or at least they can be written in a rational way. So what's the difference between a rate and a ratio, do you remember?
Ratio is like a number to a number, and then a rate is like how far something goes in comparison. I don't know.
It could be that, yeah. So a ratio is comparing a number to another number, yes, a count to a count. But what's unique is that the counting unit is gonna be very similar or the same. So if we counted up you guys, there's 1, 2, 3, 4, 5, 6, 7, 8 of you. And if I put you into two different categories and I said, well, you're biologically male, 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 1, 2, 3, 4, 5 female. We could then say that there's 5 female to 3 male. That's the ratio of females to males in the room right now, for students at least. And what's going on here is we're comparing people. So there's the common unit. That's what makes it a ratio. And you say, well, we got 5 girls, 3 boys. That's a ratio. Now, a rate could be a little bit different. Like if I looked at all 6 of my classes and I counted up how many girls I had in each class, and then I averaged it out, I might be able to come up with a certain number of girls per class. So, you know, I don't know what it is, but let's
It's like
just,
averaging,
what's that?
it's like averaging.
That would be a way to do it. It could be an average. It doesn't have to be an average though, not necessarily. It could be a one-time thing. If I took all of the girls that I have, so let's just make up a number. Let's say I have 55 girls in classes, and I have that per 6 classes. This could be thought of as a rate. It's the rate that I interact with female students. I don't know if that's all that relevant. Maybe a better rate would be something like miles per hour. And that's the really common one. So if something is traveling 45 miles in 1 hour, that's a common rate. And what's unique about this is that there are 2 different units. That's what makes it a rate. It compares counts with different units, whereas a ratio compares counts with the same units. Girls and boys are still considered to be students or people. That's the difference between them. So do you, I don't know what I was just gonna say, move that one. Do you have any questions? Homework. Yeah, and homework's on Google Classroom.